Now let's go to our next concept of this case 3 when it's projected downwards. A question says, particle is projected downwards from the top of a slope which is inclined at 30 degrees to the horizontal, the initial direction of motion being an angle 45 degrees to the slope. If the particle first strikes the slope 2 seconds after projection, find the initial speed of projection and the range down the incline. Here we have been given the time the particle is in air. Yeah, and then we have been given the angle of projection, and we have been given the angle of the angle of inclination of the plane. So we sketch. When we sketch that out, this is what we have. So I assumed my initial point is A and it's landing at B. You sketch that out, and then also you resolve for gravity, as you can see up there. So here, what are we going to do? I want the initial speed of projection and the range down the incline. What do we know? What facts do we know here? We know that the displacement from the plane AB is 0. When the particle is at point B, the displacement is 0. So that's one fact we are going to use. Because G is already standard, it's 9.8. Yeah, it's you can see that the only unknown there may be the time. But the time is also given. So the unknown is that the speed of projection. Sorry, it's the speed of projection. So perpendicular to the plane, what do we have? We have that SY equals UIT plus a half AYT squared. Then AY is what? G cos 30, but negative, because remember the particle is projected against gravity initially. So SY is 0, then we make the necessary substitutions, and UY is U sine 45. So UY is that component of the initial velocity perpendicular to the plane. So UY is sine 45, and remember you have T. So when you substitute, this is what you have. And AY, remember, is negative. Therefore, we make you the subject. And we obtain that. We obtain 9.6 cos 30 degrees over 2 sine 45 degrees, and we substitute respectively, and we get our U as 12.0025 meters per second. But for if you want to get two significant figures, you can just say 12 meters per second as the initial speed of projection. So that is the speed of projection. Now we go to the range down the incline. Range down the incline is, you could say SX. Yeah, me I took AB, but SX, S subscript X to mean that distance along the plane, parallel to the plane. So AB is a distance parallel to the plane, is equal to UXT plus a half XT squared. So we substitute here. Upon substitution, you have, since you already have UX you just get from resolving U. You resolve U to obtain 12.0025 cos 45 times 2 plus a half into 9.8 sine 30 degrees times 2 squared. But the AX is positive because the body is moving downwards along AB, and that is the direction of the G, the component of gravitational force, G sine 30 degrees. So it's accelerating downwards with either, and it's in the same direction as the acceleration due to gravity, the component of acceleration due to gravity, G sine 30. So when we obtain that, you get your AB as 26.77 meters. 26.7741 meters as your range down the incline. So the idea in these projections on the incline is around the gravitational force. When you understand how the gravitational force is acting, when you resolve it correctly, then you will be in position to deal with these questions, because they're now like the previous questions in the other two cases. The only thing that's changing is AX and AY. So other than that that is it for this topic. And they will ask you other questions like the time. You've already seen time. They'll ask you and they can ask you maximum height, but that is going to be tricky. How? Or it may not even be tricky, because I'm sure you've understood by now that, okay, now in that case, if they ask you maximum height, let's take our diagram here. Yeah, maximum height, you'll have two reference points, or you may not. Okay, yeah, you may have two reference points, or you can just choose one. Let's choose the plane through A, the plane through point A. So let's have something like this. So if you're choosing a plane through point A, then you notice that your angle of projection becomes 15 degrees. You see how you're cutting this figure or this sketch, playing around with it to make it simpler. Yeah, so you realize it is the maximum height. Yeah, because of course it's going to go up and down. So this angle of projection, it becomes 15 degrees. And remember, you have U, so you have to find this distance. That distance. What I'm talking about is this: if you have a plane through A, like that, your maximum height is going to be this. That would be your maximum height. And remember, since this is 30 degrees, then also this is 30 degrees, because the alternate angles. That is also 30 degrees. And that leaves you up here with what? 15 degrees. And that is our sketch right here. So you can clearly find the maximum height. But then your conclusion, you'd say the maximum height is this distance from the plane through point A. Yeah, you'd use that as your reference point. Or you could use anything, any other reference point, as long as it is really clear in the question or in your diagram. Yeah, for example, if they said, if let's say it landed, if let's say this particle that was projected land, let's say point B was on the ground. If point B was on the ground, but they just said landed on the plane. If point B was on the ground, then considering the plane through point B as the you use that as your reference point. That means you'd have to get to know this distance here. So are you seeing how it becomes complicated now? So you'd have to know this distance, and this, you'd have to know this distance and this distance to use the plane through B as your reference point. But since it's all easier when you use the plane through point A, your maximum height, you can easily conclude. Yeah, other than that, I think we are done with all the cases. And after this, there is just a slight quiz that is after this that I would like you to try out. I'd like you to try out. So let's go to the quiz. The quiz, there is that the range of a projectile when launched at an angle theta is the same as when launched at the angle to theta. What is the value of theta? You may try that out, and you can attach a reason. And then there is also this one: a cannonball fired at an angle of elevation 10 degrees has a range on a horizontal plane of 1.25 kilometers. Ignoring air resistance, find the speed of projection. If the general formula for range of projectile is to be used, then it should be proved. Like you have to first derive the equation, the formula for range. So, but you already covered that. So if then the goes ahead to say, if air resistance is taken into account, what can be said about the speed of projection? Yeah, that's also for you to think about. Then 3 is just another one. Yeah, 3 is just another question. It says a ball is thrown from the top of a vertical tower 40 meters above level ground. The initial velocity of the ball is 10 or 2 meters per second at an angle of 45 degrees below the horizontal. Find the distance from the foot of the tower to the point where the ball first lands. Yeah, this you can also do it, but there is something you have to notice about this one. It says below the horizontal. So yeah, take keen note of that of that idea. That's the third. Then the fourth, we have this diagram. Yeah. So you can try out those questions in your free time. Yeah, that diagram, it's really testing your understanding. The diagram below shows a cross section of a particular fairway of a golf course. So yeah, Diana knows from experience that if she hits the ball and lands within 1 meter of the edge of the lake, then the ball will roll into the lake. Set up a model to use it and use it to solve the following problems. So the problems are there. So you can also try this out. Yeah. Yeah, with that, I think we are done with projectile motion.